Hi, my name is Jacob Stanley. I'm one of the members of Group 7. Today we're going to demonstrate our design for the Band in the Box project. We're going to go through each instrument and describe it individually before we play a track of Ode to Joy. First, I will let the team introduce themselves.
Hi, I'm Hans Janssen. I designed and developed the high-frequency percussion instrument.
Hello, I'm Cory Onigkeit, and I developed the design for the mid-range flute.
Hi, my name is Gillogly, and I built and designed the mid-low range frequency percussion instrument. Now we will get into the description of each instrument, starting with Hans. Hans.
Thank you. I'm Hans, and I built a high-pitched percussion instrument. The goal was to create an instrument with frequencies in the high range with a focus on size and affordability. What I came up with was a wooden design, a wooden board with dowel pins, and a cut-up wooden dowel for the bars at different lengths to create the different frequencies. This is a little bit different from the original design in the fact that it's not aluminum and it is a little bit shorter, so it fits in the box better. I found aluminum to be more expensive, and the final cost for this particular instrument was $9.25. While building this instrument, I learned how to size material for creating different frequencies. In order to improve this design, I would like to try different materials and different sizes. Up next is Cory with the wind instrument. Thank you.
Thank you, Hans. And now to present the mid-ranged wind instrument. The major design features of our wind instrument is the mouthpiece, the finger holes, and the end cap. The design has changed from the proposed design in the overall tube length and the finger hole positions. This was done to better achieve the sound quality and tone range required. During this process, I learned exactly how these flutes work and a great respect for the flute makers of the world. The major challenge involved in producing this instrument was in the acquisition of tools to actually make it. Blowing across the mouthpiece of the flute produces a pressure wave in the tube. The note can be changed by uncovering different finger holes, which changes the frequency of the waveform. Some design improvements that can be made are a plug instead of a cap for better tone quality, better fabrication facilities, and a lip plate on the mouthpiece. My sources were How to Make a Homemade PVC Flute and Make and Play a Paper Flute, the boring version, both available on YouTube. And now Justin will present the mid-low range percussion instrument.
Thanks, Cory. Hi, my name is Justin Gillogly, and I built and designed the mid-low range frequency percussion instrument, which was a collapsible xylophone. This xylophone has a couple of important features, including the inclusion of red oak wood, along with metal bolts, nuts, and washers along the edges. The sound is created by either shortening along the edges or bowing out from the middle, whether you need to increase or decrease the frequency of each piece of wood. I would improve upon this design by adding rubber grommets along the edges to be able to reduce the impact of the metal into the sound, along with boxing in the entire project. I also used a wood mallet for this, and it would be better off using a mallet that is wrapped in some sort of felt or rubber. The total cost for this project came in at $14.32, which was just under budget. Sources include How to Make a Xylophone from wikihow.com and The Ultimate Speed of Sound list from soundrolling.com. And now, on to Jacob with the low-range frequency guitar. Thank you.
Hi, it's Jacob again. I'm going to describe the low voice instrument, or the string instrument that we came up with. The instrument is made from wood with a few metal components. The physics of a stringed instrument rely on the tension, the length, and the linear mass density of the string. Tension is held on the string at one end by the bridge and saddle, which are made from a piece of threaded rod and metal spoon, and on the other end with another piece of threaded rod and machine heads that allow me to control the tension. Using a Diario spec sheet, I was able to figure the fret spacing that I needed to be able to hit the range of notes I wanted. The sound of the vibrating string reverberates within the hollow body, and the sound is amplified. The extra holes allow a musician to add an electronic pickup whenever he feels like it, or has the money. The only notable reference I used was a spec sheet from the D'Addario company that provided ideal tensions for all the strings that they produce. And the instrument also plays. And now check out our budget. Thanks.
All four designs did an excellent job in reducing costs when stayed well within budget, with a total project cost of $44.
And thank you to Maroon and Gold 4-Band for having us design their instruments. Also, I want to thank Cory and Hans for their contribution with their instruments, as well as none of this would have been a possibility without them. I hope all of you enjoy your instruments that we made for you and will work with us in the future. Thank you, and have a great day.